Welcome to Elemental Energy, the podcast where we discuss how to simplify decarbonization. Here, we will introduce emerging low-carbon energy technologies and give you insight on how to navigate and support the evolving energy landscape. It is our goal to develop content to give you confidence to help transition the market and make low-carbon energy reliable and affordable. I'm your host, Marcia Leonard. Today's episode, I am joined by a woman who I've been admiring from afar after listening to a few of her podcasts, and particularly after listening to her Entrepreneur Hour that was hosted with Michigan State. She has so much confidence. She is an absolute leader in the sustainability space, and I'm really looking forward to getting to know her a bit better through the conversation that we are about to have over small-scale nuclear reactors. And we're going to be discussing the company that she works with, along with their extremely innovative way of approaching how they are making these projects economically viable. So without further introductions from me, Michelle Brechtelsbauer, welcome to Elemental Energy.
Thanks so much, Marcia. I'm really excited to be on the show.
Oh gosh, Michelle. So I would love for you to introduce yourself a little bit further so our audience knows who that we're speaking with today.
Yeah, sure. So my name is Michelle Brechtelsbauer. I'm currently the Vice President of Strategy with Last Energy based in Washington, D.C. My career before coming to nuclear really kind of straddled chemical engineering and public policy. I studied chemie as an undergrad and then grad school, which is where I kind of caught the policy bug and became really excited about, exploring career pathways that would allow me to have a greater impact in the world. And that's what led me down towards that kind of science and technology policy space, and eventually moved to Washington, D.C., where I worked for about 4 years on science policy topics of vast range, from Earth observations to STEM education, climate change, and a little bit of nuclear. But it wasn't until about 5 years ago when I was actually approached by Last Energy CEO and founder, Brett Kogelmass, to join his company, that I really started to get into nuclear energy. And it's very much been kind of my focus of my career and of my every single breath for the past 5 years is, how can we ensure that this amazing technology can live up to its potential to really help enable the global energy transition to cleaner world, but also, live up to that potential of having abundant, clean energy for everyone.
So one thing that really draws me to Last Energy is the size and the scalability of it. So these 20 megawatt reactors, would you please introduce Last Energy and the concept a bit further?
Sure. So the company really was founded first and foremost to address the challenge of climate change and the challenges of energy access and energy poverty. So that's kind of been our driving thesis. How do we address those challenges? And then we came to, the energy technology suite. And we looked at all of these technologies and found that nuclear power in particular had the biggest potential, given its advantage from a physics perspective. The energy density of nuclear energy is just absolutely incredible. It also obviously has other advantages in terms of accessibility that really allow it to potentially scale to meet those challenges at global scale. But then when we looked at how it was being deployed, we saw that it was highly, stagnated in the industry, or in terms of its deployment, where about 10% of our global energy supply today comes from nuclear power plants. There's really only about 400 power plants operating. 300 of them are called pressurized water reactors. And that's not really near the level of penetration that you'd want to see for this technology to be as ubiquitous as it potentially could. So what we did is we looked at what were the true drivers of that stagnation. And that's what ultimately led us to the design decisions as well as the business model decisions that we have today. So to get to that kind of technology, on the technology side, to get to that 20 megawatt size, we looked at what technology do we have that's proven, that supply chains exist, and that we can quickly scale to meet that near-term challenge of climate and energy access. And that's what led us to the pressurized water reactor technology. They mentioned it's the most common type of power plant operating today. So we kind of stuck within that technology camp. But then we also looked at outside of the nuclear sector. We look at the oil and gas sector, the power generation sector, the renewables industry. How do they innovate to ensure that they can scale to, scale their operations? And, these energy industries have enormous footprints globally. What lessons can we learn from the technology side there to apply to nuclear to enable that same level of scaling? And that's where modular construction really came in as a critical factor for us, mass manufacturability. So our power plant is at that small size so that we can essentially build hundreds of them in order to scale to larger energy sources or energy sizes that might be required. So our power plant is made up of about 40 individual modules that are skid-mounted steel frames where all the equipment is located inside of each of these modules. Those are produced in a factory setting, and then they're shipped to site and assembled to make this kind of small, power plant that when turned on produces that 20 megawatts electric or about 80 megawatts thermal. And what's really critical about that, the manufacturability and that factory fabrication process, you get quality control, but you also are able to, standardize a product. So you used the word reactor earlier. This is something that the nuclear industry does a lot. They call our technologies the reactor, but it's much more than just a reactor, right? The reactor is just the hot rock that produces the steam to turn the turbine and eventually produce the power. But it's the whole power plant that we're packaging. So our power plant, we're essentially designing that whole power plant to be modularly manufactured. So that's kind of on the tech side. And then on the business model side, which I'm sure we'll go into a bit more as well, what we're selling to customers is not a power plant, not a reactor. We are selling energy, electricity, under a standard power purchase agreement model. So those are kind of the two innovations that we came with: a small manufacturable power plant that is completely standardized and productized, and a delivery mechanism via a power purchase agreement model to deliver energy to energy customers, and packaging those together so we can actually kind of achieve that vision of helping industries decarbonize.
So I'm going to let you in on a secret of how I came to know and understand Last Energy a bit better. At being a tier one EPC company, we look at the outside of the nuclear island, like how we can support the engineering, the balance of plant kind of. And I was like, wait, Last Energy is packaging everything.
Mm-hmm.
And that was so impressive to me to see how you guys took everything under your wing in order to make it. There's not as many stakeholders that need to be there. You have a much better hold on the economics of the projects themselves. So go ahead and expand on that just a little bit more, because you guys have even gone so far as to remove external funding. Am I correct?
Mm-hmm. Yeah. So again, our goal is to deliver energy. And if that's your goal, then you have to ensure that your business is set up so that is what you ultimately achieve. So today's projects, you kind of break it into all of these different contributors. You have your reactor designers, you have your EPCs that kind of design the rest of the plant. You have your financiers, you have kind of all these different actors. And those incentives across each of them are going to be very different. None of those stakeholders in kind of the traditional model, for none of those stakeholders is the goal ensuring electrons get on the grid, right? Today's nuclear designers or the traditional kind of reactor vendors, they just want to design something and hope that an EPC picks it up and hope that a project, ultimately gets developed. By putting all of that under the Last Energy umbrella, we are ensuring that we ultimately achieve that goal of getting clean electrons on the grid or behind the meter. And so that's the rationale behind it. It also ensures that, when we have goals around time to delivery, that it is on us as opposed to on a project partner to ensure that we actually do deliver on our contracts. The government funding piece too, it's less about kind of the stakeholder piece, but it's less about the delivery piece for the government financing and why we don't take government financing, and more about that time factor, right? So by going so small with our design, we've also been able to shrink our capital costs to ensure that we can use private sources of project capital or traditional infrastructure capital, just like the rest of the power generation industry does. And by ensuring that we have private sources of capital, we're actually reducing a lot of risk by having to rely on governments for financing, be that through, a contract for difference mechanism or, some other sort of government grant or government sponsorship project where if the politics change or, you have to go through a competition or some sort of competitive process, you don't actually have control any longer. So we've just essentially eliminated that as a variable for ourselves by ensuring that the cost of our plants are so small that we can use private capital.
Everyone listening, you just heard the super secret ninja sauce coming from an Obama administration policy advisor on how to make these projects come true. So thank you for sharing that. Okay, applicable customers for these smaller reactors. Like I hail from an oil and gas background, and what I've been really looking into is the feasibility of integrating nuclear into industrial application spaces, specifically oil and gas. Like I'm even looking at offshore. I mean, could you imagine it would remove like the seismic activity risk on it too? Like how cool would that be? Marine-based nuclear. So let's talk about your ideal customers for this reactor.
Yeah. Well, I guess my answer won't really speak to a single one because it's really any customer that needs baseload power. So, if you're looking for obviously clean is a benefit, but you might not even care if it's clean. You're looking for, baseload electricity and or heat. Right now, you don't necessarily have too many options depending on where you are. So let's say, you're a business in the middle of the United Kingdom and, you're looking to expand your operations, or maybe you're looking to replace an existing asset. In the UK, you do have carbon standards that are going to require you to look for clean sources of electricity. And if you need 24/7 electricity, then you're not going to be able to do too much without nuclear, right? So renewables are going to be too intermittent for you. Maybe you don't have enough land to site all of those solar panels or wind turbines, and it's also really difficult to get a grid connection in many of the countries where we're operating in Europe. So you're then looking at baseload sources like waste to energy or other sorts of CHP, maybe CHP with carbon capture. But really, the kind of ideal option would be a small nuclear power plant that can sit right next to your site, and you can do a private wire right behind the meter directly into your facility for both electricity, and ideally, you'll also have a use for heat as well. So we're working with lots of different types of industries, from data center hyperscalers to vertical farms to cement manufacturing, food and beverage manufacturing. Really, anyone that has a need for that baseload power, we're working with. I think that the niche, though, for us is in terms of our size, right? So a single power plant is 20 megawatts, but if we're working with a customer that needs 100 megawatts of electricity, we just build 5 of the exact same plant side by side. And so we can essentially scale to meet the level of demand that customer needs.
So super interesting concept, because some of the other technologies that we were looking at, they're integrated into the asset itself. But what I see, your application is it's its own power plant. And that is the ideal application, is to set it next to your asset in order to power it. Okay. I have a better understanding now. Thank you for that.
Yeah. Yeah. And it doesn't have to. I will say, you don't have to actually co-locate these assets near a factory. We can do what's called a virtual PPA as well, where it's essentially, and you're still going through the grid. But I think what we found a lot of demand, especially given grid constraints in Europe. This is less of an issue in the United States, but in Europe in particular, where connection queues are into the mid 2030s right now in most places. Having that optionality to go behind the meter is really critical. And then if you're looking for heat, we do want to locate within 10 kilometers so that we, don't have too long of a pipe network that needs to bring that steam to your site to ensure that it's still at the right temperature.
So let's keep talking about a couple of differentiators that sets you guys apart, because there are so many SMR and advanced reactor technologies that are coming online right now and vying for the market. So keep going with the differentiators, please.
Yeah. So I guess, yeah, listeners of your podcast will definitely know what SMRs are, I think, at this point, but maybe just to back up. So SMR means small modular reactor. Other terms in this area are advanced reactors. Last Energy we like to call ours a micro reactor just because it is a lot smaller than some of the traditional SMRs. But you're right that they're not every SMR, vendor or I guess designer has the same kind of service offering, output, business model, or customer base. We're all pretty different in some of these areas. Last Energy is on the pressurized water reactor side. There are other types of reactor technologies. For example, there's boiling water reactors that are proven. There are other reactor types that haven't yet been proven, but are kind of new, and that's where you get some of these advanced types. So some of those technologies are relying on maybe new fuel types or new reactor physics or new reactor chemistries that are maybe a few more years down the line before they'll be fully proven. I think the biggest differentiator aside from the reactor itself will be in terms of the scope that the company actually takes on in terms of that delivery. So some reactor designers literally just focus on the reactor itself. Last Energy is pretty unique as well in that we focus on the entire power plant. A few others also focus on the entire power plant. When we say the word modular, depending on the size, that word can kind of be corrupted, right? So at 20 megawatts, our entire power plant is modular. As I said earlier, every single kind of Lego piece is a module of the full power plant. Whereas some of the ones between 300 and 500 megawatts or really 100 megawatts and above, they're only making some components modular. So maybe their pressure vessel is actually made up of 3 independent pieces, but it's not a skid mounted module that you would think of like from the oil and gas kind of perspective. So that's another differentiator. And then the business model is really different. I think really only Last Energy is focusing on that full service delivery model where we are not only designing, financing, licensing, but also building, owning, and operating our assets through their entire lifetime, taking on that full service.
So people are literally just paying you for your power output.
Yeah. And that's really critical, right? Because if you are that theoretical business in the middle of the United Kingdom, all you care about is your operations, making the widgets that you make. You don't want to also be operating a power plant. You just want to sign a contract and ensure that you have, fixed priced, long-term supply of electricity, and that reliability is really what is so critical for those customers.
When you guys decide to make a marine-based application, please let me know. Because that's something that we're facing wholeheartedly when it comes down to some of the marine integration is the owning and operating is who really wants to take on that risk. And so, I mean, even land-based, how amazing that you guys are willing to take that on in order to deliver the energy. That's so cool. Okay, let's talk about how many projects you guys have slated. I think last I checked, it was in its 50s. Is that correct?
Yes. Yes. So we went out to market in early 2023, taking, essentially what we've already been talking about directly to customers in 4 countries, the United Kingdom, Romania, Poland, and the Netherlands, and engaging with potential customers. And we've signed PPAs with about, I think, 9 so far, representing about 50 or over 50 power plants in terms of our order book. So our order book is already very large. We're looking at our first projects to come online in just a couple of years. We're going through the licensing process in those countries as well. That is a differentiator, right, between traditional power as infrastructure development and nuclear, is that in every single country where you build a power plant, you have to get a license by that country's nuclear regulator. So we're starting those processes as well. But yeah, so we have a pretty solid order book to date already. And that's why, ensuring that our product, our power plant, can be mass manufactured is so critical, right? We're building the exact same thing every single time. The only thing that changes is the site. But even there, in terms of how the construction method is sequenced and the techniques we use there, we're also trying to standardize that as much as possible.
Let's talk timelines. When is this first power plant actually going to happen?
Well, I will caveat by saying it definitely depends on how quickly you can get through these regulatory processes. But we are, estimating that if everything goes kind of according to plan, we could be looking at our first projects coming online into 2025, 2026 at the earliest. But of course, there is potential for the licensing processes to go shorter. But there's nothing that is kind of saying that we couldn't do that if everything worked well in terms of our development process.
So, have you experienced or has your team experienced that it's easier to work with regulatory committees outside of the United States? Is that why you chose those markets to initially go out to?
Yeah, so we chose our markets actually through a very a very extensive process. We actually started with a list of about 30 countries and then have narrowed down to the four where we're currently operating in. And what we were looking for was actually a lot of different factors, about 75 factors that we evaluated across each of these markets in an increasing level of resource commitment as we were looking into them. But it really comes down to a couple key areas. One is regulatory environment. So we're looking for regulators that are obviously, very mature and have the expertise to license our type of technology, but also a regulatory framework that credits our design for the simplicity that it has, right? At 20 megawatts, this is a fraction of the size of a traditional, over a gigawatt scale power plant. And so it's a lot simpler. Not only is it simpler in terms of the smaller amount of components that you need to look at, but it's also a much simpler safety case. And so we wanted to ensure that the regulators we were working with would ensure that the timelines and the proportionality of the regulatory process would actually be proportional to the size and the safety case and the reduced risk of our plant given that size. So that's one component. The other is really just economics. So, right, so when we're looking at places for our first of a kind deployments, we want to ensure that we have, an attractive market for which to sell electricity in. Because again, we aren't selling power plants, we're just selling energy. So we're looking at which energy markets have, a good economics in terms of pricing, which markets are familiar with the PPA structure, some aren't, and which have customers that are willing to be first movers on new nuclear.
Okay, I know that you guys have addressed this gap already, but please explain how we're going to combat the waste because since it's so small, you can't store it on site like a normal conventional power plant. So what are we going to do with the waste?
So you can store it on site, but yeah, it's definitely a lot less waste produced, again, proportionally to the larger type. So in our design, we actually keep the waste. So essentially, we operate our reactor in a batch of like a battery in 6-year batches. So there's essentially 7 cycles that run for 6 years. And at the end of each of those cycles, the previous reactor core actually just stays underground. It's actually operates. It's subterranean design. It stays where it is until the whole plant is ultimately decommissioned. So we don't have like a separate warehouse on site where we have to take fuel rods out and then go store. It actually just stays exactly where it was for the entirety lifetime of the operation facility. And then at the end of the lifetime of that asset, it depends on the country as to how waste is dealt with. I can say in most countries, there are plans for, some of them haven't been fully realized, but are plans for deep geologic storage, where that would mean that at the end of the lifetime, that waste would get shipped to a site to be disposed of in that way. Some countries are looking at reprocessing, is what France does. And then, of course, we have designed in the case that there is no policy solution, it could also safely be kept on the site, until that policy solution comes to bear. So we kind of have designed our waste storage solution to give us options for the policy environment that we're in. But it is up to the government as opposed to the reactor designer.
Do you think you could convince Brett that you and I need to go visit Yucca Mountain just to do a tour and like
I would love to see it. That'd be fascinating. That'd be fascinating. Yeah.
Oh my gosh. I was looking up that there is a museum that has waste. Did I hear that on
Yes.
your E-hour? I
You
believe I
might
heard on
have.
yours.
Yes.
Okay.
Yes. I would also love to go see that. But yeah, I mean, waste is stored in the environment it creates is similar to, I guess, if you wanted to have a nice wine cave where you had temperature controlled, et cetera. And yes, if you're storing some, precious national artworks, it's a great place to also store those. And of course, it's contained safely, so you can walk right up to spent fuel casks and touch them. There's a great photo of a nuclear advocate who, when she was pregnant, went to visit a site and hugged a waste storage cask. Absolutely, that was such great kind of marketing and branding. But yeah, it's perfectly safe as well to be around.
So if you have time, look up for everybody listening, Corva. It's in the Netherlands, and it's literally a beautiful museum, and there's spent nuclear waste in the background on top of it. I just thought that was amazing, like how they're turning it into art. It even goes as far, I don't know if you saw it, I looked it up, that the building is going to fade colors from this vibrant orange down to like, a peach over time to show the
I did not know that.
degradation.
Wow, that's cool.
That's like that's the nerdiest art I've ever heard of, and I love it.
That's awesome.
Okay, so we've talked about the waste, we've talked about the business model, we've talked about the technology itself. Is there anything else that just is totally setting Last Energy apart that you want to address while I have you here, Michelle?
Yeah, I mean, I would say for us, it's really about like that mission driven kind of motivation as a business is so critical to our DNA. If you don't know much about our origin story, we actually started out as an organization called the Energy Impact Center. This was kind of in that research phase that I described earlier when we were trying to understand, how to make the biggest impact on climate change, on energy access, on energy poverty. And I think that driving mission is so critical to all of the decisions that we make, how we structure our business, how we move forward in the world, how we think about marketing and what is actually progress. You won't see Last Energy putting out press releases about signing MOUs, right? We'll put out press releases when we've got spades in the ground and when we've signed actual deals and we've turned on clean electrons. I think it's a really critical culture in this industry. We're really trying to disrupt an industry, one that sure has been stagnated in terms of delivery for, real challengeable reasons, but also one that has been complacent in its stagnation. And that's, from my perspective, from Brett's perspective, from our team's perspective, completely unacceptable. And we are not alone in that perspective, though, in the sector. A lot of the new startups in this space have come to nuclear power because of its decarbonization potential and its real potential to change the world. And I am just, really honored to be part of this next generation of nuclear innovators amongst my peers in this sector who just really care about the impact they're trying to have and don't just see this as a cool technology, but see this as, a pathway to creating a better future for everyone.
Now, Michelle, a question I don't always ask my guest on elemental energy, but I really do want to ask you is because you have stepped into this role as a leader in the sustainability space, and you're you're still quite young, and you're paving pathways that are just, they're so admirable. And it's really important to see other women, especially in STEM, who are promoting themselves and what they believe in. Like, how did you actually, what gives you the confidence to be who you are other than passion? And what advice can you give to other people who might need to hear this?
That's a great question. I think what gives me the confidence is that I've come to the opinions that I hold about this technology, about, its impact through my own research. I mentioned the podcast, journey that we went on with Titans of Nuclear. When I first started working here, and when most people, start working here, we don't just say, okay, now you work for a nuclear company, here's the lines to regurgitate, here's how you feel. We let our employees to have space and really come to love what they do and believe in what they are, pushing towards from a personal place. In fact, Blast Energy intentionally tries to hire from outside of the nuclear industry whenever possible, or maximally possible, right? So our nuclear engineers obviously are going to come from the nuclear sector, but pretty much everyone else we try to pull from, other energy comparable sectors where people not only know how to build things, but they know how to like really actually deliver. And if we can convince, people who've built hundreds of power plants, in their careers to switch over to nuclear as the technology that they start to build, then we'll actually be able to kind of see that difference come through. So yeah, I think for me, it's about having that personal journey to find my own conviction and, but also always questioning. Right. So that's one of the things I love about podcasters, right? I love what you're doing. You're going on your own journey right now, to discover kind of the pathway to decarbonization that you are going to become the most passionate about. You're probably starting to formulate your own theses through this process that one day you'll be on a stage talking about. And I think that's just really important to give yourself space to go on the journey so that you can then share that journey with others.
Wow, you just had I just had a total affirmation moment. I have been asking, how to get people to embrace the energy transition. And three of the points that I'm writing about right now, I'm writing a book called The
Oh,
Enlightenment of Energy.
nice.
And it talks about how electricity and oil and gas have a relationship, and people really need to understand that to better understand the energy transition. And my first point is curiosity, second point, research, and third, connect. So it's like having the curiosity, like you said, to build your own, like, what is this? What is that? Build your own thesis and come up with what you think are your thoughts and building further to have support around them and becoming that expert in the space. Oh, Michelle, it's been such a pleasure having you on Elemental Energy. I just look forward to seeing what Last Energy does, but also you, like, continue to be the advocate that you are and the sustainability champion and the woman leader in this STEM space. And I'm just wishing you all the luck, and I can't wait to follow your journey.
Amazing. Thank you so much. Same to you. I look forward to reading your book when it comes out.
Yeah. So everybody listening, as always, stay happy, but most importantly, stay safe, and we'll see you in a few weeks. Michelle is a rock star. I want to be her when I grow up. Just the women that I have encountered in nuclear, including Grace Stanke. I have another podcast with her, Miss America, previous Miss America. Go back, check it out. The women in this space are just phenomenal. They're so confident and they're stepping into it. And I took a lot away from that interview, but just more affirmation that there need to be more women in this space, because the ingenuity and the innovation and just the different kind of thought processes that are being delivered from Michelle and her team, of course, it really is showing in how Last Energy has set themselves apart to be these small power plants of the future. If you have any questions about the conversation that happened today, please don't hesitate to reach out to me. I love this stuff. I love talking about it. So I'm absolutely happy to connect with you. And even if you have a perspective that you may want to share on elemental energy, let's connect. Let's become friends and see how we can help elevate each other in this space.
That is your chance to be